let internal energy be a function of temperature and volume. And then I will prove that it is not a function of volume. Same way again I will proceed and prove that internal energy is not a function of pressure. And finally, it is a function of temperature only. This will be for an ideal gas. And then same way we will start discussing about the real gas. So du can be written as del U by del T at constant volume into dt plus del U by del V at constant temperature into dV. du is also TdS minus PdV. Heat transfer delta Q, which is TdS, this is du plus PdV. So du can be written like this. And then we had two TdS equations. Do you remember first TdS equation? No. And while deriving, I told you that subsequently, if you don't remember, you will not be able to proceed further. As Maxwell relations, if you don't remember, you cannot proceed. Try to write down all the four Maxwell relations and the two TdS equations without referring the back pages. You have not to do for me, you have to do for yourself and see how much do you remember. And if you don't remember, that means last week you have wasted your life minus the last week. And same way, if many weeks get negative, what will be left? Now please check up del T, del P, del S and del V. This V on this side, this T on the other side. del T, del P, del S and del V. This P and the other side T. Del T, del P, del S and del V. Del T minus del P, del S and del V. कितने लोगों का ठीक है? काफ़ी लोगों का ठीक है। अब कितनों का गलत है? एक। काफ़ी अच्छी प्रोग्रेस है। अब TDS इक्वेशंस, TDS इज इक्वल टू CV dt प्लस V कांस्टेंट dV T del P by del T, and also Cp dt minus T P dP and del V by del T। ये कितने लोगों का ठीक है? 1 2 3 4 5। इसमें हिंदुस्तान मार खा गया। कोई बात नहीं। One equation we had entropy taken as the function of temperature and volume. So ds was written as del S by del T keeping V constant into dt plus del S by del V keeping T constant into dV. No difficulty up to this. Next, multiplied by T on both sides. TDS set constant volume CV dt, this dt is there, that means this part becomes CV plus T. Since we are writing TDS equation, on this side there should be no term with entropy. Del S by del V at constant temperature. This is to be replaced by some Maxwell relation. No. This is del S by del V at constant temperature. This is given by del P by del T at constant volume into dV. Further, I had given you the method to remember it. TDS, if you are writing in terms of CV dt, this V should be kept as constant into dV. Other property left is P, so del P by del. Okay. Second, ds s to be taken as the function of temperature and pressure. So ds shall mean del s by del t keeping p constant into dt plus del s by del p keeping t constant into dp. Multiplied by T on both sides. TdS at constant pressure, heat transfer, Cp dt. This dt is there, so this term is becoming Cp dt plus T, and now del S by del P at constant temperature. This will be replaced by minus del V by del T at constant pressure into dP. Thus, TdS is equal to Cp dt minus T del V by del T at constant pressure into dP. अब इसको कैसे याद रखना है? ये सी वी डी टी वाली थी, अब दूसरी इक्वेशन है सी पी डी टी वाली. सी वी छोटी चीज़ थी, इसमें ऐड करना था. सी पी बड़ी चीज़ है, इसमें से सब्ट्रैक्ट करना है. पहले टी लिखना है. देन दिस टर्म पी रिमेन्स कांस्टेंट हियर, एंड देन दिस साइड डी पी. प्रेशर टेम्परेचर आ गए, बाकी रह गया वॉल्यूम and del V by del T. याद हो जाएगा? अब यहाँ इस डेरिवेशन के लिए मैंने पूछा था TdS क्या लिखेंगे. ठीक, इंटरनल एनर्जी वाली बातचीत हो रही है, तो वो वाली इक्वेशन TdS Cv dt plus T V constant dV del P by del T. This is TdS minus PdV. This may be written as Cv dt plus T del P by del T at constant volume minus P into dV. We started assuming U as a function of temperature and volume. And U we have been able to discuss in terms of temperature and volume. du as a function of dt and dv. This is equation number 1 and this is equation number 2. Let us compare the coefficients of dt and dv. For dt, del u by del t at constant volume is Cv, which somebody stated as per Joule's law, du is equal to Cv dt, whatever may be the process. So this holds good. Other term, del u by del v at constant temperature shall be T del P by del T at constant volume minus P. Now, for an ideal gas, PV is equal to RT, P is equal to RT upon V. Why I am writing like this? Because I want del P by del T at constant volume. R is constant, V is constant, differentiating T with respect to T is 1. Substituting it there, del U by del V at constant temperature is T, and this term is R upon V minus P. What is RT upon V? P. That means when I say del U by del V at constant temperature is 0. That means on this side there was no term like V, that when we differentiated it has become 0. That means U is not a function of volume. U is not a function of volume. That means U may be a function of pressure and temperature. So now what I should do? U, P and T. V should also come. So far, the various relationships we have studied, they were connecting only 3. Two rotated, third keeping constant. Now we would like to have a relationship connecting 4 terms. Let us say x, y, z and another function f. These are the 4 terms. Let me rotate the 3 keeping the 4th constant. That means del x by del y keeping f constant into del y by del z keeping f constant into del z by del x keeping f constant this should be equal to what? If this term remains constant throughout, they can straight away be getting simplified. This cancelling, this cancelling, this cancelling, it becomes 1. That means if I come across pressure, volume, temperature and entropy in an isentropic process, entropy remaining constant, del P by del V, del V by del T and del T by del P, this is equal to 1. Now, I am having U, V, P and T constant. I can write del U by del V keeping T constant into del V by del P keeping T constant into del P by del U keeping T constant, this is equal to 1. This would mean del U by del V at constant temperature may be written as del P by del V at constant temperature into del U by del P at constant temperatures. Now a very important step. This we have proved del U by del V at constant temperature is 0. So this should be del P by del V at constant temperature into del U by del P at constant temperature. Now be very careful. Product of these two terms has to be 0. Either this is 0 or this is 0. What is this term? Temperature remaining constant. That means isothermal process. Boyle's law. Pressure and volume are inversely proportional to each other. If pressure increases, volume will decrease, or volume increases, pressure will decrease. That means del P by del V at constant temperature is non-zero. Out of the two, if this is non-zero, that means this must be 0. Therefore, del U by del P at constant temperature should be 0. This will mean U is not a function of pressure. U is not a function of volume. U is not a function of pressure, and hence U is a function of temperature only for an ideal gas.